Hello everyone, I'm François from Shakmat, and in this video we will have a look at the Ballista Blast. The Ballista Blast has a hybrid digital-analog architecture. So the module features a digital core made of VCO and modulation signals processed by an analog process chain. This chain is made of VCFs, VCA/LPG, two types of distortion, and a final VCA to adjust the level. Note the digital core also generates different modulation signals such as an Assignable envelope, a randomizer, and a velocity manager. Let's now check the key elements of the front panel. Those four potentiometers are the main controls of the synthesis engines. These are harmonics, emphasis, parameter, and pitch. Speaking of the pitch potentiometer, as in every Shakmat module, you can log the pitch potentiometer, which acts now as an octave switch. So let's unlock the pitch potentiometer by passing through the previously stored value. Now we have the Alt button, which allows an alternative behavior of the VCO/parameter control. Here, at the right of the module, we have an Assignable envelope with the attack and decay/release controls. The LED and menu buttons allows you to assign the envelope to the four main controls. We'll have a more in-depth review of this part later in this video. Here at the top we have the trigger button, which shows the activity of the module VCA, and it also allows you to manually trigger your Ballista Blast. At the left of the module you have an OLED screen with two pairs of buttons. Upper buttons allows to change the page of a menu, as the two lower buttons allows to change the value inside a page. Below the screen we have three buttons which give access to the main synthesis menu, oscillator, analog, and modulation. Speaking of menus, at the top of the module we have two buttons which allows to enter the randomizer and velocity menus, and below we have the save and load buttons which enter the memory menus. Here we have all the jack connectors for gate input, all the CV input and the audio output, and finally we have here a SD card reader. Let's now explore the main synthesis menus, which are oscillator, analog, and modulation. The first menu, which is the oscillator menu, allows to edit different settings of the oscillator. The first page of the oscillator menu is the engine page. Engine is a key concept of this module. Engine defines the type of synthesis used by the VCO. but it has also an influence on the analog chain, as we will see later in the engine chapter of this video. To navigate through the different engines, use the two buttons below the screen. So let's stick for now to the classic engine. Second page for the classic engine is the mode page, but you will find different pages according to the type of engine used. So here we can scroll through the different modes, such as sub, dual, unison, sync, width, and so on. In the next chapter of this video, we will have a more in-depth review of each mode of the classic engine. Now let's go to the third page of the oscillator menu, which is the octave page. It allows you to transpose the VCO by octave, from -3 to +3 octaves. Let's start a sequence. The sequence comes from the Bishop's Miscellany Mark II, and let's transpose to different octaves. The pitch potentiometer has a range of 3 octaves. Fourth and last page of the oscillator menu is the FM/AM input mode. Here you can switch between FM, linear FM, or AM. That's it for the oscillator menu, and let's switch now to the second menu, which is the analog menu. In classic mode, the first page is the VCF type. Right now we are listening to the two-pole low-pass filter. Harmonics control the filter cutoff frequency, as emphasis controls the filter resonance. Let's switch to the next type of filter, which is the two-pole bandpass. Next filter type is a high-pass filter, also a two-pole filter. And the fourth and last type of filter is a four-pole low-pass. As you can hear, it sounds more liquid and acid than the two-pole version. Let's now switch back to the two-pole low-pass filter. And let's check the second page of the analog menu, which is the VCF tracking page. We can set this parameter from 0% to 100%. At 100%, the filter tracks the VCO. Next page is the VCA behavior. VCA can be driven by the envelope, or by the gate input, or can be set in drone mode, meaning the envelope does not affect the VCA anymore. Let's switch back to envelope mode. Next analog menu page is the distortion. Distortion can be disabled or set to 5 different levels of distortion. On the next page, you can set the distortion type. First type we were listening to is a symmetrical soft clipping. Second type is asymmetrical and leads to more even harmonics. Let's disable the distortion. Last page of the analog menu is the level. At 0 dB, the output amplitude is 5 volt peak to peak. Level can be set to +3 dB, +6 dB, or can be lowered to various values. Output can even be muted. Let's go now to the third menu, which is the mod menu. This menu displays different settings for the onboard envelope, or if connected to the expanders, which are active but not affecting the patch we are hearing. First page of the mod menu is the envelope mode. Here we have a classic triggered attack release envelope. Second mode is AD for attack decay. Third one is a gated attack sustain release envelope. As you can hear, the Ballista Blast is following the gate length of the Bishop's Miscellany Mark II. Fourth mode is a loop envelope, which resyncs with the gate input. Let's switch back to attack release mode. The second page of the mode menu is the envelope shape. You can set the release to linear or exponential. Let's now talk about the classic engine. This engine is all about saw and squares with a regular subtractive synthesis approach. Let's go to the second page of the oscillator menu to check the different modes. In order to listen properly to the different modes, we set the VCA to drone mode and we close the filter. So let's open it. In every mode, parameter gives an additional control to the VCO. Now we are listening to the first mode, which is the sub mode, and the parameter crossfades the original wave with the sub-octave -1 octave waveform. In classic mode, the Alt button allows to switch between saw and square waves. Let's go back to a saw wave and let's now look at the second mode. This is the dual mode. We have two saws and parameter acts on the relative tuning of the second saw. Let's use the Alt button to switch to square waves. Third mode is unison, so here we have four saws mixed together. Parameter acts on the detune amount. Unison squares. Next mode is the sync mode. As you can hear, parameter is the tuning of the synced waveform. Let's switch to saw. The next mode is a width mode. Here we are controlling the saw width. And of course we also have pulse width. Here you can achieve classic PWM sounds. Next mode is a noise mode, where you can crossfade the waveform with white noise. Let's switch to the last mode, which is the chord mode. Parameter acts on the chord structure. Here we have unison, fourths, fifths, and then different minor chords. Afternoon we're switching to major chords, to finally go to different dissonant chords. Second engine is the Wavetable Engine. The Wavetable Engine provides the same analog chain as the classic engine, so VCFs with tracking, distortion, VCA, and so on. As in the previous chapter, the VCA is in drone mode and we have to open the filter to hear the waveform. There are 32 tables of 8 waves. We go to the second page of the oscillator menu to select which table is used. We will listen now to the factory wavetables, but it is possible to import your own user wavetables. Check the user manual on our website for more information about this. Parameter morphs the 8 waves of a table, and we are now going to listen the first wavetable, which is the basic wavetable. The next tables are sets of digital waveforms. With the Wavetable Engine, the Alt button enables an ensemble unison mode. The ensemble mode really shines with more harmonic wavetables. Let's switch to the second tables of digital waveforms. Let's go to DG3, DG4, DG5, 6, 7, 8, 9, 10, 11. The four next wavetables are a set of chiptunes wavetables. Then we have four four-man wavetables. Then we have a set of four harmonic wavetables. Those sounds really nice with the ensemble mode. Now we have a set of acoustic instruments wavetables. First is cello, guitar, pluck. This kind of wavetables shines when modulated with the envelope, Rode, saxophone, trombone, and the two last wavetables are vocal wavetables. Those two wavetables sound very well with the ensemble mode. Let's now talk about the FM engine. While working with the FM engine, the analog chain is a bit different as it does not use the filters. Harmonics and emphasis adds two more macro controls to the FM algorithms. Let's now explore the algorithms, so let's switch to the oscillator menu second page. The algorithms relies on predefined FM structures. Harmonics is usually the modulation depth, parameter the modulator relative tuning, as emphasis as various functions. Let's go to the analog menu and switch the VCA to drone mode. We are listening to the fold algorithm with one modulator, one carrier. Here harmonics sets the depth of modulation of the modulator to the carrier. Parameter sets the relative tuning of the modulator. Emphasis controls the gain of a wavefolder. Let's now talk about the Alt button. For all the FM algorithms, it allows to switch between a free or irrational ratio mode to rational ratio mode, which leads to more harmonic results. The potentiometer does not have a discrete action, but instead we are cross-fading rational ratios for the modulator frequency. Here the ratios are simply octaves. Second algorithm is a bronze algorithm. The core of the algorithm has two modulators in parallel. Here, emphasis adds a bit of distortion and a bit of a high-pitched modulation. The key with FM is to modulate those parameters. For example, this emphasis parameter is very nice when modulated by a short envelope. Let's switch to more simple ratios. As you can hear, the result is more or less harmonic depending on the chosen alt mode. Third algorithm is a servo algorithm. It gives nice results for leads and more synthetic sounds. This algorithm relies on two modulators in serial. Emphasis controls the FM feedback. Let's switch to more simple ratios for the modulators. And let's go back to more complex ratios. Next algorithm is the Ferro algorithm. Here we have two carriers, each modulated by its own modulator. Here, emphasis is a complex process of distortion, high-pitch modulation, and AM. Let's push the Alt button to have more simple ratios. Again, as in any FM synthesizer, such controls are intended to be modulated in order to create more interesting patches. Next algorithm is the additive algorithm. In this algorithm, the harmonic controls set the mix of the sine waves. The parameter control sets which bank of sine waves is used. As the alt mode is not activated, the frequency of the sine waves are in a complex ratio. So let's engage the alt mode, and as you can hear, we have now more simple frequency ratios. An obvious application is to mimic organ sounds. With this algorithm, emphasis adds a high-pitch modulator. Next algorithm is the flux algorithm. Here we have a pretty simple structure with one modulator and one carrier, but the trick is the emphasis control sets the amount of noise sent to the frequency control of the carrier and modulator. This algorithm is useful to create wooden percussions or windy textures. Again, we'll use the Alt button to have more harmonic ratios. Last algorithm is the chord algorithm. The chord structure selection is the same as in the classic chord mode. Harmonics sets the amount of modulation of an octave modulator. As emphasis sets the amount of modulation of a high-pitch modulator. When pressing the Alt button, you switch between two modes which provide more or less detuning of the different voices of the chords. Let's have a more detuned feeling. Let's now check the Ballista Blast envelope section. The envelope has a control for attack and decay, and we have different settings we already saw in the modulation menu, such as the release shape or the envelope mode, such as attack release, attack decay, attack system release, and loop. For now, we will stick with the attack release mode. Let's go back to the oscillator menu. We have a sequence running in the Bishop's Miscellany. Let's start it. Let's now check the depth potentiometer with the small menu with 4 LEDs and a button. This menu allows you to assign the envelope to different destinations. Those destinations are harmonics, emphasis, parameter, and pitch. Let's add some depth to harmonics. Let's set back the envelope depth to harmonics to 0, and let's now assign the envelope to emphasis. Now we have more resonance at the beginning of each note. Let's set back the emphasis depth to 0, and let's switch to the next destination, which is parameter. We are in sync mode, so we're gonna modulate the frequency of the synced wave. It is of course possible to assign the envelope to several destinations. So let's keep this depth for the parameter destination, and let's switch to the pitch destination. Parameter LED is dimmed, meaning this is active but not selected, and the pitch destination LED is blinking, meaning it's selected, but the value does not reflect the pitch depth. So we have to turn back the depth potentiometer to 0, which is the actual pitch depth, and the destination LED is now on, meaning we are controlling now the depth of the envelope into the pitch control. Let's turn back the pitch depth to 0, and let's go now to the harmonic destination, and we can add a bit of envelope to harmonics. So you can actually assign the envelope to every destination at the same time. Let's now switch to another engine. Let's go to the FM engine, for example. There is a pretty easy way to clear all the destinations at once. To do that, just press and hold the envelope button for 2 seconds. So let's now add a bit of depth to the harmonics control. Let's shape the release with an exponential curve. So here we assign the envelope to the harmonics control. Let's also add a bit of depth to emphasis. Let's switch to another FM algorithm, the bronze algorithm. Let's remove the envelope assignation on harmonics, so we have to catch back the value and go back to 0. And let's switch to emphasis destination. Let's go and set back the value. Let's increase the attack time. And again, you can clear all the destinations at once by pressing and holding the button for 2 seconds. The Ballista Blast features a randomizer which allows you to add randomness to your patch, from humanized feeling to IDM result. To enter the randomizer menu, just press the randomizer button. In this menu, you can set amounts for almost any destination you can think of, Each destination has its own random generator and its own random depth. Available destinations are level, distortion, harmonics, emphasis, parameter, pitch, depth, attack, and decay. Let's add a bit of random to harmonics and let's start a sequence. Here the Ballista Blast is set to a very simple classic mode patch with sync mode, a low-pass filter, and distortion. Let's add randomization to harmonics. Each time a rising edge is received into the gate input, it will fire the randomizer. Let's now switch to emphasis. So every time a new gate will hit the gate input, we will have a different emphasis amount. Let's add randomness to the parameter destination. At low level, the pitch destination gives a bit of detuning, reproducing the behavior of old analog synthesizers. At high random values, you can have more IDM results. Let's switch the pitch destination amount to 0. Depth randomizes the depth for all the active destinations of the envelope. Next destination is attack. We can also randomize the release/decay. As with the envelope, you can clear all the randomizer destinations at once by pressing and holding the randomizer button for 2 seconds. The Ballista Blast has a velocity input which can be assigned to a lot of destinations. To go to the velocity menu, press the velocity button. The velocity menu works the same way as the randomizer menu. You can scroll all the destinations and set independent amount for each destinations. We are now using the FM engine and we'll start a sequence. Sequence is coming from the Bishop's Miscellany Mark II, and we are using a Griffin's clause to control the velocity input. Let's assign the velocity to the level destination. Another destination is the distortion. You can also assign the velocity to the randomizer. This is a quite special destination. The randomizer destination allows to control by voltage the amount of randomization thanks to the velocity input. Check the user manual for more details. Let's keep on moving into the velocity menu. So we have harmonics, for example, and let's increase the amount for this velocity destination. So we have harmonics and level now, but let's add also a bit of velocity on emphasis. You can of course assign velocity to parameter, pitch, depth, attack. Again, emphasis and harmonics are already assigned. And let's go to decay, which is a nice destination for our velocity. Let's record an automation with the Griffin's clause. As with the envelope and the randomizer menu, you can clear all the velocity destinations by pressing and holding the velocity button for 2 seconds. The Ballista Blast has a non-volatile memory of 256 presets stored into the module EEPROM. Presets can be imported or exported thanks to the SD card. This is useful to store your presets or import presets from one module to another. Let's start a sequence. We will here edit a patch and show how to save it. Let's go to the FM engine. Let's choose a different algorithm. Okay, let's tweak the module a bit. Let's lock the pitch. Okay, we like this preset, so let's press the save button. We are now in the save menu. Let's choose one of the 16 banks with the 2 buttons up the screen. And with the 2 buttons down the screen, we can choose a slot inside a bank. So we'll choose bank 1, preset number 15. We press the save button and the preset is stored. Let's go now to the load menu to load the preset. We load the first preset of the bank number 1. Bank 1 number 2. Bank 1 number 3. It is also possible to preview the presets by holding the load button while being in the load menu, and you can now hear every preset just by scrolling them. This is a silent preset. This is factory bank 3 with more percussive sounds. The load menu also provides 2 additional options, which is for the preset init, so it will give a very basic patch. This patch has no destination for the envelope, the randomizer or the velocity input. Let's now switch to the last option of the load menu, which is the random preset. This will create a completely random preset. Presets might be silent because the filter can be completely closed, for example. Another silent preset. As we already talked about, the Ballista Blast has a SD card reader. The SD card reader allows 3 different things, which are firmware upgrade, importing user wavetables, and importing or exporting your presets. Go to our product page on our website to have more information about the file structure you need to have on the SD card. For firmware upgrade, you have to press the trigger button at startup and follow the instruction on the screen. In order to import your own wavetables, you have to press the velocity button at startup and follow the instruction on the screen. Wavetables are WaveEdit format. Check our website to find the user manual and find more information about the user wavetables. Last but not least, the SD card can be used to import or export your presets. As we said earlier, the Ballista Blast does not need an SD card to be able to load and save presets, as the presets are stored on the internal EEPROM of the module. To enter the preset management mode, press and hold the Save or Load button at startup and follow the instructions on the screen. To finish this video, we will have a look at the global option menu of the Ballista Blast. To enter this menu, just press the analog and mod buttons at the same time. Oscillator, analog and mod buttons are now blinking alternatively. The global option menu allows to edit different settings. Those settings are global and are not saved into presets. First page is the potentiometer mode. This defines the behavior of the potentiometer when recalling a preset. You can choose between 2 different behaviors. First one is jump, meaning you simply have to turn a potentiometer after recalling a preset to unlock this potentiometer. Second one is catch, meaning you have to pass by the stored value in order to unlock the potentiometer. This allows to avoid jump values when recalling a preset. Let's keep the potentiometer mode to catch. Second page is only available in catch mode. It is a catch display. Catch display is a visual helper which shows the direction a potentiometer should be turned in order to catch the preset value. To demonstrate this, let's load a preset. When moving a potentiometer, as you can see, the screens tell me to turn the potentiometer clockwise. When the potentiometer gets to the preset value, the screen shows OK. Let's switch back to the potentiometer jump behavior. We'll now go to the next page of the global options menu, which is the select bus page, where you can enable or disable the reception of select bus messages. When the reception of select bus messages is enabled, you can use a module such as the Harlequin's context to load or save presets on the Ballista Blast. Let's now move on to the next page, which is the screensaver page. This will allow us to turn automatically the LED screen off when not using the module. You can set to off 5 minutes, 15 minutes or 30 minutes. Next page is the wavetable page, when you can set the wavetable to be from the factory sets of wavetables or your user wavetables. Note you have to first import your user wavetables in order to set this to user wavetable mode. Next page is Expander 1 page, where you can enable or disable your expander. You have also a second page for the second expander, where you can enable or disable the second expander. Next page allows to set the behavior of the depth potentiometer for the envelope. This can be set as an attenuator, as we did until now, but you can also set it as attenuator. A little note about the attenuator mode. If you created a preset with attenuator mode for the depth of the envelope and you recall the preset while the module is configured in attenuation mode, the depth value will be set to 0. Let's switch back to attenuator and let's move on to the next page, which is the Expander 1 depth behavior. This sets the behavior of the depth potentiometer for the first expander. Let's switch to the next page, which is, of course, the same for the depth behavior for the second expander. And we're back to the first page. This is it for the Ballista Blast video user manual. Thanks for watching and see you soon. Bye bye.